All right, welcome to our day 3 recap of Advent of Code for 2022, doing all of these problems in Haskell. So this problem was another fairly easy and straightforward problem. As we can see from our input, we're really just reading in lines of strings. All of these are letter characters, so nothing complicated in parsing. What we basically do is, for the first part, is we divide the word into two halves. So we have the second half, we have the first half, and basically there is only one letter that is in both halves, and we just have to find that letter, and we have to score that letter. So for this first example, only P is the letter that appears in both halves of this word. Is in the first half here, is in the second half here, and we can do the same thing for each of these other examples. And then we just provide a score for each of those letters we found for each of these words. And so lowercase letters get 1 through 26, uppercase letters get 27 through 52, and we just add them all together. The second part, the only thing that really changes is that we divide our input lines into groups of 3. So we have 2 groups of 3 here. And within the groups of 3, basically there's only one letter that is shared amongst all 3. So looking at this example, we have these 3 lines, we have these 3 lines. So the first group, the only letter they all have in common is the lowercase r. And in the second group, it's the capital Z, capital Z. We just have to find those common letters and then score them. So the code for this is actually pretty straightforward. This is a very easy parser to write. Each line is just a string, and so we do our line by line trick, and within each line we're just doing some letter chart. Very easy. So again, we're going to use a folding pattern. So basically our fold type, we're just keeping track of the score as we go through line by line. It starts with a score of 0, and then there's the question of, okay, how do we incorporate each line into this? So with part 1, we just divide the input into 2, so we get the compartment size. We divide first half, second half, using our helpful split at function. And what we can do is we can filter the first half based on, is this character a lem? Is it a member of the second half? And then we can use nub to deduplicate that. Basically, we expect that this will give us exactly one character in each case. We can log an error message if that doesn't happen and just return the previous score. Otherwise, we want to add a new score for this character. What does our scoring function look like? Well, if we just open up our ASCII table, it's not too difficult. Basically, so we want the uppercase characters to be the numbers 27 through 52. In order to get that, we just have to take the ORD value of that, the ASCII value of that, and subtract 38. Because I think capital A is like 65, and so 65 minus 38 is 27, I think is how that ends up working. For the lowercase characters, lowercase a starts at 97, so we have to subtract 96 to ensure we get 1 through 26 on those. But that's basically all there is to it. We score the character, we add that to the previous score, and we just incorporate that into our fold, and we'll get our result. And it's all very easy for the second part. Nothing changes too much. One key here is we have to say chunks of 3. So basically, this is Haskell's nice little helper to take our input lines and just break them up into groups of 3. So fold hard, the hard version part 2 of this problem, we take a list of strings. We expect it to be exactly 3. If it's not, we'll just throw an error. Not throw an error, but log an error and return the previous score. That's a helpful thing about this folding pattern is, like, our default is like, okay, we'll just return the previous fold value. We won't incorporate this, but we'll log an error message. That's kind of nicer than like throwing an error a lot of times, although you'd have to be a little more careful in your debugging. And now we'll do something very similar to what we did in the first part. We use the same sort of filter process. This gets us all the characters that are in both string 1 and string 2. And then we do that one more time with string 3. So we say, okay, give me all the characters in this intersection that are also in string 3. I think that's actually the first time I thought of the word intersection while solving this problem. There might, it might have been easier to just use sets and use an intersection function, but this is the method that occurred to me as I was trying to write this as quickly as possible, racing the clock last night. And then once again, we deduplicate, we use the nub function, and we have the same expectation that there's exactly one character. We add its score, and that's pretty much it. And that's enough to get us the right answer. There are, like I said, using a set is not just, maybe not just easier to understand, code-wise, but it is actually probably going to be more efficient to do it that way. This is, if each string, we consider that, sorry, that's wrong input from day 4, upcoming. If we look at like day 3, none of these strings are longer than like 50, so it's not a big deal that our algorithm is a little inefficient. But if we consider this, okay, O of m is the size of a string, then our deduplication process is O of m squared, when really you should be able to do, you should actually be able to do that in O of m time, using hash sets and that sort of thing. But at the scale of this problem, it's not really necessary, and for at least the way I'm approaching these problems, I'm trying to optimize for like what's the fastest solution I can deliver in terms of my time to try and get on that leaderboard as quickly as possible. So that's what I'm optimizing for, rather than speed necessarily. But as we get into some of the harder problems later on, optimizing the algorithm will actually be very significant, and the scale of the problem will be very important. So there will be more of that later. So that's all for day 3. We'll be back tomorrow, hopefully, as long as I have time, for day 4. So stay tuned for that. Subscribe to Monday Morning Haskell, the YouTube channel, of course, but also our newsletter. There's a link for that in the video description, so don't miss out. Thank you very much.